Hi, it's the Science Chef again. In this video, which is a remake of our very first video on this channel, and as a way of marking our second year anniversary, you'll learn about the blast furnace and the reactions that occur in it. So, if you want to know the raw materials used for extracting iron and their functions, then endeavor to watch this video to the end. Generally, a furnace is a forge or workshop where the smelting or extraction of a metal from its ore is carried out. When the process is achieved using a blast of air, the forge is called a blast furnace. The blast furnace, which is commonly used for the extraction of iron, is externally made up of steel, while its internal surface is lined with a refractory material such as graphite. A refractory material is one that has a very high heat resistance. This is important because since the melting points of metals are generally high, where they are to be extracted must be made of materials whose melting points are higher than theirs. Iron is extracted from its ore by chemical reduction, and the raw materials used are limestone, coke, and the ore. The commonly used ore is haematite, which is made up of iron 3 oxide as its main constituent. It also contains silicon 4 oxide or sand as impurities. Other ores of iron include magnetite, limonite, siderite, and iron pyrite. The iron ore, limestone, and coke are collectively known as the charge. Another important raw material in the extraction of iron is the blast of hot air, without which no reaction will take place. So, now that we know what the blast furnace is and the raw materials used in the extraction of iron from its ore, let's now look at the various reactions that occur at different parts of the furnace. Firstly, the charge is fed into the furnace from the top of the furnace. Then the blast of hot air is pumped into the furnace through pipes called tires, but spelled 2 R's. These pipes are located at the bottom of the furnace. Which of the components of the charge do you think will react with the hot air? Limestone, coke, or hematite? If your answer is not coke, then you are wrong. So, at high temperature of about 2000 degrees Celsius, the coke reacts with oxygen at the bottom of the furnace in an exothermic reaction to form carbon 4 oxide. This reaction must occur at this high temperature because even though it is exothermic, it is a non-spontaneous process as carbon cannot react with oxygen at room temperature. So being an exothermic reaction, the heat generated in this reaction is enough to heat up the furnace throughout the remaining process. This means that the coke is acting as a source of fuel in this process. The reaction, apart from being exothermic, is a redox reaction in which carbon is the reducing agent that is oxidized to carbon 4 and oxygen is the oxidizing agent that is reduced to the oxide ion. The heat generated in the combustion of coke is needed to decompose the limestone into quicklime or calcium oxide and carbon 4 oxide. This is a thermal decomposition and occurs at about 1800 degrees Celsius. The calcium oxide produced in the reaction combines with the silicon 4 oxide impurity in a neutralization reaction to form calcium trioxosilicate 4, which is removed as slag. Can you explain why this reaction is said to be a neutralization reaction? Not really. Okay, it's simple. It's a neutralization reaction because calcium oxide, which is a basic oxide, reacts with silicon 4 oxide and acidic oxide to form calcium trioxosilicate 4, which is a salt. The two reactions can be compressed into one and rewritten as calcium trioxocarbonate 4 plus silicon 4 oxide to give you calcium trioxosilicate 4 and carbon 4 oxide. The carbon 4 oxide gas produced in equations 1 and 2 rises to the middle of the furnace and is reduced by the excess coke at about 800 degrees Celsius to carbon 2 oxide in an endothermic reaction. In this reaction, carbon is both oxidized and reduced to carbon 2 oxide, and it's known as a comproportionation reaction. This is a redox reaction in which the same element in the oxidizing and reducing agent undergoes changes in its oxidation state to form the same product. To learn more about redox reactions, watch our complete series on redox reactions. We have added the link in the description. The carbon 2 oxide gas produced in the middle of the furnace rises to the top of the furnace and reacts with the iron 3 oxide to form molten iron and carbon 4 oxide. This reaction, which is an endothermic reaction, occurs at a lower temperature of about 400 degrees Celsius. In the reaction, carbon 2 oxide acts as a reducing agent because it reduces the iron 3 oxide to molten iron and itself is oxidized to carbon 4 oxide. The molten iron sinks to the bottom of the furnace while the slag formed in equation 3 floats on top of it due to its lower density than iron. The covering by the slag prevents the hot molten iron from being oxidized to iron 3 oxide again by atmospheric oxygen. The molten iron is then tapped off as pig iron for further purification, while the slag is used in road construction for road surfacing. The unreacted carbon 2 oxide gas in equation 5 and the carbon 4 oxide gas produced in that same reaction with the unreacted nitrogen from the blast of hot air are given off as waste gases at the top of the furnace. In summary, the functions of the raw materials used in the extraction of iron from its ore are as follows. Coke is used as a source of fuel and reducing agent for the process. Limestone is used for removing the earthy impurities as slag. Haematite contains a high proportion of iron 3 oxide that is reduced by carbon 2 oxide to iron, while the blast of hot air serves as a propellant for the combustion of the coke. The reactions occurring at different levels and the constituents of the waste gases are as shown on the screen. So if this video was helpful to you in any way, kindly drop a comment and give us a like. Also, if this is your first time here, subscribe to our channel and turn on your notification bell to always stay updated with our new uploads. A wise man once said, act as if you can't buy a loaf of bread until they find out you own the bakery. So stay humble until I see you when I'll see you.